So let's look at a typical question. So in this particular question, you're told the equilibrium constant Kc for the following reaction is 0.0211 at 300 K. Of course, the temperature is given to us because it's important to know what temperature it is. PCl5 in the gas phase is in equilibrium with PCl3, also in the gas phase, plus chlorine gas. And we see that the equation is balanced. And the question is, what are the equilibrium concentrations of all of the species if the initial concentration of PCl5 was 1.00 molar? And so anytime you get a question that is talking about equilibrium concentrations and how to calculate them, the first thing you want to do is you want to think about the fact that you need to be able to draw an ice table for this reaction. And so if we look at this, the first thing we would do is to say, well, we want to know that we have a balanced chemical equation, which we do, which is a good thing. The next thing we would want to know is, because we're talking about equilibrium, we could write the equilibrium constant. So Kc at equilibrium, of course, is the value of Qc, and initially we talk about the fact that it's the product over the reactants, and depending on what the stoichiometry is, in this particular case they're all 1, so they're not raised to a particular power. And then the next thing we would do is we would draw an ice table. And so you always want to set them up in the same way, with the equation at the top, and then you want to have I, C, E, initial, change, and equilibrium. And we know the initial value, because it's given to us, is 1.00 molar PCl5. And because this is at the initial, at the start of the reaction, there are no products because the reaction hasn't started yet. So the value of the two products is 0. The concentration is 0. And then there's some type of change before it reaches equilibrium, and that change we denote x, because x is a great variable. And we know that the initial value of PCl5 decreases, and so that's why we have minus x, because this decreases because it's a reactant, and at the same time you get an increase in both of the products. And how much increase? Well, stoichiometry tells us that. So because there's a 1 here and there's a 1 here, if we get a decrease in minus x for PCl5, at the same time we get an increase in plus x for PCl3, because there's a 1-to-1 relationship between these two. There's also a 1-to-1 relationship between PCl5 and Cl2, so this also increases by a value of x. And so at equilibrium, now we're on the E part of the table, 1 minus x is how much the concentration of PCl5 is at equilibrium. And 0 plus x equals plus x, that's the concentration of PCl3 at equilibrium, and the same is true for Cl2, for chlorine gas. And so now what we can do is, we know all of these values, and of course we're going to have to find this variable. So we take our Kc expression here and we add in all of these terms. So here's Kc. First thing we want is the concentration of PCl3 at equilibrium, so this is the x here. We need the concentration of Cl2, which is this x here, divided by the concentration of PCl5 at equilibrium. And we know that the value is 0.0211 because it was given to us in the question. And so if we multiply this through, we end up with x squared equals 0.0211, and then I've multiplied both sides by 1 minus x, and this is the expression that we get, which looks remarkably like a quadratic equation, because there's an x squared value and there's an x value and there's a term that's just a number. And so we could say this looks quadratic, so it looks very similar to a quadratic equation. And so what we want to do is we want to make this into this quadratic equation. So here's the x squared value, and so what we're going to do is we're going to add minus 0.0211x to both sides, and we're going to subtract 0.0211 to both sides, so that this equation now looks like this, which is just a rearrangement of this equation. Now this looks like a quadratic equation. And of course our overall goal is to determine what the value of x is. And because it's a quadratic equation, we use the good old quadratic formula, which hopefully you remember quite well, and we're going to use it quite often. And as long as this formula is in the same quadratic equation formula with ax squared plus bx plus c, we can use this quadratic formula. And at that point we plug these numbers in, we take these values from our expression up here. So here, for example, this is the value of b, this is the value of b, this is the value of b here, this is the value of a, which is 1. And when we use this quadratic formula, we realize that we end up with, of course, two values. One value which is 0.135 and one value of negative 0.156. Now, of course, this negative value, what we've actually been talking about, this value of x that we're trying to determine, is in fact a concentration. And a concentration cannot be negative because it's a concentration. So this is physically impossible. So because this is a negative value, this is physically impossible. So the value that we're looking for is x equals 0.135. And of course, for a quadratic equation, you always have two solutions. And in this particular case, because this one is physically impossible, the value that we're looking for is 0.135. And so at that point, now we go back to our ICE table. We now know the value of x, we know the value of x, we know the value of x, and we can use this to now determine what the concentrations are. So now we can determine the equilibrium concentrations. So for PCl5 it was 1.00 molar, the initial value, minus the value of x, which was 0.135, gives us a final equilibrium concentration of 0.865 molar. And PCl3 at equilibrium had a concentration of x, which is 0.135 molar, and chlorine gas at equilibrium also had a concentration of x, which is also 0.135 molar. And of course all of these concentrations are to 3 significant figures, as that's the values that were given to us in the original concentration. So anytime you have a question that's talking about Kc and the constant, calculating Kc or the concentration of particular substances at equilibrium, you always want to do an ICE table. Always set it up the same way, always find x, and then use that value of x to either calculate Kc if that's what you're doing, or to calculate the concentration of substances at equilibrium.